Well, hello students, welcome back to mathematics class with me, Mr. Alfie. In this video, we're going to learn about multiplication of probability for independent events. Let's check this video out. So what is exactly independent events? Two events are said to be independent events when the occurrence or non-occurrence of non-event will not affect the probability of occurrence of the other event. If A and B are the events, and A and B are independent events, so the probability of A and B equal to probability of A multiple with probability of B. Let's jump to the example. An unbiased coin and unbiased six-sided die are thrown. Let A be the event of getting a hat and B the event of getting a number greater than 4. The sample space is shown below. A and B are independent events. Why? Because A is even getting a hat, it means event A is about the coin, and B, the event of getting a number greater than 4, it means event B is about the die. What happened in the coin will not affect what happened in the die. So A and B are independent events. So tail and hat for a coin, number 1 through 6 for the die. This is the outcomes. So there are 12 total outcomes. A is the event of getting a hat. So the favorable outcomes is H1 through H6. And event B is the event of getting a number greater than 4. The favorable outcome is H5, H6 and T5, T6. So the probability of A and B is actually the multiple of probability A and probability B. So probability of A is 6 per 12 because there are 6 favorable outcomes and 12 total outcomes. Multiple with 4 per 12 probability of B, there are 4 favorable outcomes for B and 12 total outcomes. So probability of A and B is actually equal to 1 per 6. Next example, a bag contains 2 red balls and 1 green ball. 2 balls are drawn at random from the bag, one at a time with replacement. Remember, with replacement. Let A be the event that the first ball drawn is red and B be the event that the second ball drawn is green. Find the probability of A and B. A and B are independent events. Why? Because A is the first drawn and B is the second drawn. Whatever you get at the first drawn will not affect whatever you will get in the second drawn. So this is the illustration. Let's say this is the bag that contains 3 balls, 2 red and 1 green. Whatever you take at the first drawn, you have to return it to the bag and take another ball from the bag, whatever the ball it is. That's how it happens. So this is the 3 diagram that show the probability. R for red ball and G for green ball. So the probability got the red ball at the first drawn is 2 per 3 because there are 2 red balls, and the green is 1 per 3. There are 1 green ball. And also the second ball is 2 per 3 because you return the first drawn. And green also 1 per 3 and repeat it here. So now we are going to find the probability of the red at the first drawn and the green at the second drawn. This is the favorable outcomes, red and green. So the probability of red at the first and green at the second is from 2 per 3 times 1 per 3 equal to 2 per 9. Next questions. Mina has 7 English stamps and 5 Singapore stamps. So it means Mina has 7 plus 5, 12 total stamps. Nurul has 12 English stamps and 18 Singapore stamps. So Nurul has 12 per 18, 30 total stamps. Each girl selects a stamp at random from her own collection. Find the probability that the two stems selected are one English stem and one Singapore stem. So whatever Mina take at her stems will not affect whatever Nurul take at her own stem. So these two events are independent. Now this is the tree diagram to show the probability of Mina and Nurul. The probability Mina get E English stem and S Singapore stem. Probability of Mina get English stem is 7 per 12 and for Singapore stem is 5 per 12. For Nurul, for English is 12 per 30 and for Singapore is 13 per 30. So the probability of one English stem and one Singapore stem, this is English and English, English from Mina and English also from Nurul. This is English stem from Mina and Singapore stem for Nurul. SE, it means Singapore from Mina and English for Nurul. SS means both of them got Singapore stems. So one English stem and one Singapore stems. These are the favorable outcomes for that probability because one English and one Singapore. So the probability of one English stem and one Singapore stem equal to probability of English Singapore plus Singapore English. So it equals to 7 per 20 plus 1 per 6. So equal to 31 per 60. Next example. The probability that Xiuming will hit a target is 4 per 5. The probability that Gary will hit the same target is 3 per 4. If each of them fires one, find the probability that the target will be hit by both of them and only one of them. So the probability of Xiuming miss the target is 1 minus probability Xiuming will hit the target is actually equal to 1 per 5. So the probability of Gary will miss the target 1 minus the probability Gary will hit the target, so equal to 1 per 4. So this is the tree diagram that shows the probability. Xiuming hit the target 4 per 5. It's known from the question. And then the probability of Xiuming miss the target is 1 per 5. And Gary, the probability hit the target is 3 per 4 and miss the target is 1 per 4. You repeat it here. And the probability the target will be hit by both of them is H and H. It means both of them hit the target. So this is the favorable outcome for this probability. So the probability is 4 per 5 times 3 per 4 from here and here equals to 3 per 5. So the probability is 4 per 5 times 3 per 4 from here and here equal to 3 per 5. Next, probability the target will be hit by only one of them. It means the probability of Xiuming hit the target and Gary missed it, or Xiuming missed the target and Gary hit it. So equal to probability of HM plus MH. Only one of them hit the target. So 4 per 5 times 1 per 4 from here and here plus 1 per 5 times 3 per 4 from here and here. So equal to 7 per 20. Next example. The probability that a worker contracts a lung disease due to occupational exposure to dust is 0.2. 3 such workers are checked at random. Find the probability that none of the 3 workers has contracted a lung disease. So if the probability that the worker contracts a lung disease is 0.2, so the probability the worker does not contract a lung disease is 1 minus 0.2 equal to 0.8. And then this is the tree diagram that shows the probability. C for contracts the lung disease and N for does not contract a lung disease. So we're going to find probability of none of them has a lung disease. It means this is the favorable outcome for that probability, none of them. So the probability of and equal to 0.8 multiplied with 0.8 multiplied with 0.8 equal to 0.512.